the primary mirror is loose, continuing the story of the 200 PDS and the large circles which were in all of the data from literally every image that I captured. Thanks to you guys, loads of you said internal reflections must be internal reflections of a variety of types. So for example, within the tube, within the focuser, and within the coma corrector. So I did a test with removing the coma corrector and then adding the coma corrector back in. I ran a test where I took some light frames from the same object in the sky with and without a coma corrector. I also took flats for each of those scenarios as well, and dark flats, and I had a darks library anyway, so that's fine. And I was then able to stack them together and compare the results. This was really interesting. So I'll show you the first image here. This is with the coma corrector. You can see a blue circle on the images there. This one is without the coma corrector, and you can still see the blue circle in the image. This is really interesting because it tells me that if it is a reflection, that it's not the coma corrector. And I fed this back to the supplier and they said, okay, so it's not the coma corrector. Please can we have the telescope back and we'll look at the telescope. And I thought, okay, that's fair enough. So I boxed up the telescope. Yeah, this one here.
That's your receipt.
That's great.
Then we're all done.
But while I was boxing the telescope up, something happened which got me thinking. I could feel something move slightly, just tiny bit. And I realized that the primary mirror was moving. And I decided to have a closer look. The fact that the primary mirror is loose means that when the telescope is guiding, that as the telescope slowly moves, over time the primary mirror is going to slowly move, which would explain why my light frames don't show the circle and my flats don't show the circle, but when they're all stacked together, the data produces that circle. So the resultant data has this large circle on it, but in a light frame, which is here, you can't see. Yes, there's vignetting around there and there's a gradient because I took this when it was full moon, and on the flat you don't see the circle either, which is really interesting. And that would make sense if the primary mirror was moving very slightly, but over the course of an entire night, when that's stacked together the data wouldn't calibrate. And then I remembered I had some issues with my Orion data. When I blinked it, I noticed the star shapes changed. If you look at this Orion data, which I've just loaded, I'll zoom in on the stars and then you'll be able to see what I'm talking about in better detail. So now we've got two stars and you can see there's a flare going off to one side. If I now blink through this data, you'll notice that the flare disappears over time. So the star is getting sharper and then it goes. I'll slow it down. So if I just stop it there, and then if I blink through, so the stars there, there's a little wisp just going up slightly. But if I go further back, the wisp is much bigger. And this also explains that as the scope was guiding, the mirror position was changing, because I spend hours collimating my scopes, and with this scope, whenever I literally just turned it slightly, I found it was out of collimation again, and it was because the primary mirror was loose inside. It's really frustrating because the last sort of 6 months of owning the scope, I've had this ring in all of my images, and I think it's because when I took flats, the primary mirror was not in the same position. In other words, the optical chain had moved, and therefore the flats, when they calibrated, or rather didn't calibrate, they produced this circle and the constant vignetting. And I kind of feel that the primary mirror should at least be fixed in its mirror cell, not with pinched optics of course, not super tight, but it should not move if the scope is just guiding. This has got me thinking, could it be that my 130 PDS has a loose mirror as well? So I'm going to take that apart, and I'll probably use the opportunity to do another mod as well. I'll probably put an Aperture Mask on, which will help with blocking out the mirror clips which are holding the mirror in place. Don't know how easily you can see that. It's a little bit dusty, but it's not too bad. The thing I'm really interested in though is this mirror loose? The mirror is loose. If I zoom in a bit, you'll see. If I just zoom in, you can see all the dust, but that's not actually too bad. But watch the mirror cell if I go right up to the edge, and then I'll just reframe. You can see the mirror is actually moving. That's not good. So what I think I'm going to do is fit this aperture mask that I've got here, which will fit over like this. And then at the same time, I'm going to put some little pieces of rubber underneath the mirror to prevent it from moving. And while I'm here, I think I'll give this mirror just a quick clean. So these are completely tight, but they move quite freely. You can see they put little pieces of cork underneath, so I'm going to put little additional pieces of cork, and they have to be offset, so the screw holes are here and these are just slightly past the screw holes. So I'm going to give this mirror a little clean, and then we'll reassemble it all. So this is rubber from an old bicycle inner tube. I'm just going to cut it into 3 pieces, and all I'm going to do is put them on there. Now these are rubber, they're quite spongy, so I'm not too worried about pinched optics with these. Let's just position these on. Then I'm going to put my aperture mask on. Now that feels like the mirror is really well held. It certainly isn't moving in its mirror cell anymore, and now I've got the aperture mask as well.